Okay, so we're back again with week 6. And week 6, we're going to review things that we did before March break, so before we left. And then next week is going to be taking this stuff and adding to it. So we're talking about direct and partial variation, calculating slope, x and y intercepts. So if there's anything here that you don't quite understand, try going back to the notes that we did in class. Some of it will be the same, but it has a little more explanation to it, and because this is more of a summary of what we did. So let's get into it. Types of variation. So we have a direct and partial variation. They're two different things for linear equations, and there's 3 different forms of it. You'll see a table of values, a graph, and a general equation. So a table of values, if we were to look at x and y, if you have direct variation, you'd have 0, 0. Now let's say 1 is, I don't know, -5 and 2 is -10 or something like that. It doesn't matter. As long as you have 0, 0 in your table of values, that makes it direct variation. If you have partial variation, then it'll be 0, anything else. It doesn't matter what it is. It could be 0, -10, it could be 0, 5, doesn't matter. As long as it's 0 something, then it's partial variation. You have an initial value. So if there's an initial value, that means it's partial variation. And if we're looking at the graph, because it goes through 0, 0, it has the point 0, 0, direct variation would go through that point, whereas partial would not. So it would start somewhere else. It doesn't necessarily have to be going up or down or positive or negative, just not 0, 0. So that would be partial variation. And if we're talking about the equation would be y equals, and I'm just making this up, let's say it was 3x. For direct variation, I wouldn't be adding or subtracting anything because your initial value is 0. It's almost like I'm doing this, plus 0. But we wouldn't write that. It would stay as 3x. Whereas partial variation would be something like 3x plus 10. We'd have an initial value. So in all of these situations, you have an initial value. Table of values, I see the coordinate 0 something else, initial value. For a graph, it doesn't go through 0, 0, so it has an initial value. For an equation, if I'm adding or subtracting anything, then it has an initial value. So it would be partial variation. If none of those things exist, it goes through 0, 0, or I'm not adding or subtracting anything to the equation, then it's direct variation. Okay, so that's direct and partial variation, a summary of what it is, 3 different ways to recognize it. Now, we're talking about slope. Again, we've done this before. Just reviewing it. So, slope. Slope is the rate of change, your delta y over delta x. So, we calculate our first differences, and first differences mean we see what is it going up or down by. So in this case, it's going up by 12, and we would find that by subtracting the second value and the first value. So we're taking away this from this. So 24 minus 12 is 12. And if you keep doing that, you know that it's going up by 12 each time. So our first differences are 12. And just to make sure, we need to look at our delta x as well. That's increasing by 1, so that's good. So my first differences tell me that it's linear because they're all the same. And it tells me that the slope is 12 because delta y over delta x, slope, the difference in the y's over x is 12 over 1, or 12. So that's your slope, or rate of change. So here we have to be a little bit careful because I can see that even though figuring out the delta y, the difference in the y's, isn't too hard, it's -5 because it's decreasing by 5. I can't just assume my slope is -5 because now if I look at my x's, it's going up by 3. Oops, I should draw my arrows in the right spot there, didn't I? Okay, so the difference in the x's is 3. So now if I calculate delta y over delta x, my slope, I get -5 over 3. So for every value of x, my y is decreasing by 5 over 3. So that's in the table of values. You can use your first differences, your delta y and your delta x, to figure out what your slope is. In a graph, we would use our rise and our run. So remember, delta y is rise and delta x is our run. So slope is delta y over delta x, as you can see here. We also call it rise over run. So rise divided by run. And if we have 2 points, it's the difference in the y, so y2 minus y1 divided by the difference in the x's, y2 minus x1. Sorry, x2 minus x1. So that's coming from these points here, right? x2, y2, x1, y1. So I would subtract the y's to figure out the difference in those, subtract the x's to figure out the difference in those. So we find 2 points. On the graph, it doesn't matter what 2 points you pick as long as you know what the coordinates are. So if I'm looking at this first one over here, I see we have the point 0, 1. And then I go through and I try to find another point. And it doesn't matter what the point is, as long as I know what the coordinate is. So I'm going to choose that one there. It's 9, -5. And since I have the graph, I don't need to use the formulas there. I can just look at the rise and the run. So let's draw our rate triangle and figure out what delta y is. How is delta y changing? Well, I'm going down 1, 2, 3, 4, 5, 6 spaces. Since I went down, I would say -6. And then my run, or my delta x, is how far across did we go? And we know it's 9, right? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So what's the slope? M is going to be delta y over delta x, or -6 over 9. And if we simplify that, we have -2 over 3. So the slope of that line is -2 over 3. And you should always remember it's negative because the line is going down from left to right. Left to right, it's going down. Next one. Again, we choose 2 points. Doesn't matter which 2 points you pick, just as long as you can tell what the coordinates are. So let's use this, a y-intercept. And I'm going to choose a point further away just so I know. see it, so there's a point there. So we have the point 0, -2, and 2, 7. Now let's draw a triangle to figure out our delta y and our delta x. So our vertical distance, the delta y, is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm going down, but I counted down, but it's okay because it's going to be positive because the line is increasing from left to right. It's going up. So I'm not going to get a negative number. My run is 1, 2, I erased it. Is 1, 2, 3. So my slope, or m, is delta y, 9, over delta x, which is 3. And if I simplify that, that is 3. So the slope of that line is 3. Okay, so now we know how to find the slope given a table of values. First difference is, or delta y divided by delta x. Given a graph, do the same thing, it's just we can just count the boxes. So delta y over delta x, you choose 2 points and figure out your vertical and your horizontal distance and divide. Now what happens if we have 2 points? So we have the equation slope is equal to y2 minus y1 over x2 minus x1. So you just decide which one is going to be your first point and your second point. So I'll call this x1, y1, x2, y2. And then you take those and you plug it into where it is, where you've decided x, y, y2 is and y1 is and x, all the x's are. So if this is y2, that means I'm taking that 1 and I plug it in there. If this is y1, I plug it in here. And same with the x's. It doesn't matter if I make x2, y2 over here and x1, y1 over there. The order of it doesn't matter, as long as you keep it 1 and 1 and 2 and 2. So y2 is 1 minus y1, so minus -8. x2 is 3 minus 2. So 1 minus -8 is same as 1 plus 8. That's 9. 3 minus 2 is 1. My slope is 9. So the slope between those 2 points is 9. Look at the next ones here. Now if you look at the coordinates, you might notice something. If you don't, that's okay. Oops, that's a mistake. x1, y1, x2, y2. And I recommend you write out the formula just so you memorize it properly. So y2 is 6, y1 is 6, x2 is -1, x1 is 3. Now if I subtract here, I get 0 over -4, and 0 divided by anything is going to be 0. So we have a slope of 0. Now if you look at the points, you see that the y coordinates are the same, 6 and 6. That means we had a horizontal line. So the slope of a horizontal line is 0. And you'll know that it's a horizontal line because your y coordinates are the same. Similarly, if we look at the next one, you'll notice something. Maybe, maybe not. And again, I just write it out every time just so I make sure that I get it right and I memorize it properly. So y2 is 4, y1 would be 5, -2 minus -2. So I get -1 over 0, because -2 minus -2 is the same as adding 2, so we get 0. So now if I divide by 0, I use my calculator, I get an error. That's because you can't divide by 0. So here our slope is undefined. It's an undefined slope because anything divided by 0 is not defined. So if you look at the coordinates, you see the x coordinates are the same. That means we had a vertical line. So anytime we have an undefined slope, that means it's a vertical line. Or the other way around. If you have a vertical line, you know the slope is undefined. Okay. So the next part is, again, review. We did it last week. How do we graph this? So the first thing you do is plot the y-intercept, or your b value. And we know the slope is 2. And if we write it as a fraction, it'd be 2 over 1. So that means we go 2 up and 1 right. And we do that from the y-intercept. So if my y-intercept is at -3, I go up 2 coordinates, or 2 points, and 1 to the right. And there we have a new point. Okay, again, up 2 units across, up 2 units across. And you just keep doing that. Get as many points as you can. Just makes your line a little neater. Use a ruler. Connect them. Put arrows at the end. Okay, same thing here. My b value, or my y-intercept, is +4. My slope, or m, is -2 over 3. So it doesn't matter where the negative is, it just makes it a negative slope. So you know it should be going down. From left to right, it should be decreasing. So I'm going to go 2 down and 3 right. Okay, just one of the directions has to be negative. So either down and right or up and left. Doesn't matter which one. So if my slope, or my y-intercept, is 4, from there I go 2 down and 3 right. There's a new point. Now I'm going to run out of space, but I'm just going to do it again just so you see. 2 down, 3 right, and I'd have a new point over here. So now you only need 2 points to make a graph, or make a line, but it's always helpful to get more. So there we go. We have our new line. Okay, so plot your y-intercept, and then use the slope to find more points. But you see that we used the slope, rise and run, to figure out what the other points were. Okay, so now that's slope taken care of. Now we're moving on to x and y intercepts. So x and y intercepts are where the graph touches the y-axis or the x-axis. So we know how to rearrange equations. I could rearrange this into y equals mx plus b, y equals slope y-intercept form, but we're going to save that for next week. We're going to review now what we did before the break. So that's using the x and y intercepts to graph this. So first, let's find our x-intercept. So anywhere along the x-axis, let's pretend this is the x-axis. My coordinate would be whatever x is, 4, 0. Or if x is 7, it would be 7, 0. Y is always equal to 0. So I can find my x-intercept by making y equal to 0. So in my equation, I'm going to change y to 0. So 2 times 0 is 0. I have 3x equals 6. And I want to get x by itself. So I do the opposite operation, which is to divide by 3. So x is 2. That's my x-intercept. Now to find my y-intercept, I make x equal to 0, because if this is my y-intercept, anywhere along here, I'd have 0 something, whatever y is. So 0, 4, 0, 7, or whatever it is. So I make x equal to 0. So in my equation, if I change x to 0, y is still there. And I solve for y. I get 2y is equal to 6. Divide out the 2. Y is equal to 3. So I found my x and y intercept. In other words, I have 2 points. 2, 0, 0, 3. So if I graph that, 2, 0, 0, 3. They're a little close together, but if I use a ruler, it should be fine. But I can also look and see what the slope is. Down 3 across 2. So I can do that again. Down 3 across 2 and get another point. Or I can go backwards. Up 3, left 2. Just to get more points. There we have our line. So I'm just going to do one more from the x and y intercept. So we'll do C, so I have some more space. If I want to find my x intercept, I make y equal to 0. So 5x is negative 20. I'm going to divide by 5. Because that's the opposite of multiplying by 5. And I get negative 4. So our x-intercept is negative 4. So now I know that their point negative 4, 0 is on the graph. Same thing for y now. Make x equal to 0. So negative 4y is equal to negative 20. Divide out the negative 4. So y equals positive 5. So I know a point now is 0, 5. If I go back to the graph, I can graph that. Negative 4, 0, 0, 5. Again, I could get more points, but really 2 points is all I need. There's my line. Here, as long as you connect your x and y intercepts, you're good to go. And that's it. Again, this is review of what we did before March break. So if you need to go back and look at your old notes, it's also posted on D2L in a little bit more detail. But that's it. So we're just working on the assignment this week. Don't forget to like and subscribe.